Can you hear me?
Yes.
Let me connect my
Yes, sir.
Okay. Did you guys create the Snowflake account?
Yes, sir.
Okay. What about others?
Yes, sir.
Okay. How many days account it is? It is 30 days or 120 days?
120 days.
120 days.
Any issues with others while creating the account? Are we good with that?
Oh, created Saga. Good.
Okay, sure. That's good. Fine. Let me share my screen. Okay. Anyone attending today as a first class? No one?
Yes, sir. This is Vijay.
Okay.
Today is my first class.
No worries. No worries. Fine. Let's have a quick recap. And for anyone who is new to today's class, I'll come back to the course at the end of the class. I'll explain you about the course information. But let's have a quick recap what we did yesterday. Okay. I'll use something called as Snowflake. We got started with something called as Snowflake. Okay. What exactly we did yesterday? Can anyone help me? What are all things we saw yesterday?
Like we discussed, what is Snowflake, what is cloud, how
Okay.
we will use AWS in cloud, Snowflake
Okay.
warehouse. We will use Snowflake is like warehouse as well as data lake, data warehouse as well as data lake, and
Okay.
we'll use DBT in Snowflake.
Okay. Fine. We'll come back one by one. First and foremost question for you guys is what's the difference between data warehouse versus data lake versus lakehouse? Can anyone explain me only data warehouse? What is data warehouse?
Like in data warehouse, we put a structured data that is the in our table and columns format that will put in data warehouse.
Okay. Anyone apart from Mrutyunjay want to try? What
We
is
can
data
use
warehouse?
for LTAP or online transactional application processing we use for decision making. It is like denormalized format where like
Huh?
we deploy dimensions on fact tables. It is
Okay.
like a structured data as
Okay.
processing.
Okay.
Data warehouse is a collection of data from multiple sources.
Okay. Can I say it's a centralized repository for data? Can I say
Yes.
like this? Okay.
Yeah.
But what kind of data it only support is something called the structured data, where we can go and keep in a form of table that is either rows or columns. Okay. Now we know that there is some issues and we need to handle our non-structured data also. Data lake came into the picture. What do you mean by data lake? Can you give example for data warehouse? Some examples.
Snowflake, Databricks.
Teradata. We use Teradata in
Yeah.
our project like as
Okay.
a data warehouse.
Okay.
Databricks.
Synapse. Yeah, Databricks, you can say. Then
I could say net is a
Redshift,
yeah.
AWS Redshift. These all are the data warehouse. Okay, now comes something called the data lake. What is data lake?
It is another kind of storage where we can store both structured and unstructured data.
Yeah, it's also for structure as well as unstructured data. We can have something called the data lake, and example for this is
Snowflake,
okay.
Azure
Databricks.
Azure Blob and Azure
Okay.
data lake storage. ADLS.
Okay, blob. Okay. Then AWS, which I
S3.
said S3. Okay. And GCP is nothing but Google Cloud Storage. They say. Okay. Fine. Now you said something called the structure and unstructured data. I can do all I think. Then what do you mean by this lakehouse?
He provides some
Combine of data lake and the data warehouse.
Yeah.
Okay. But why exactly we need this?
In the data lake, we don't have ACID properties to update the data and all. And
Okay.
time travel, we don't have in data
Okay.
warehouse or data lake.
Okay. The limitations of data lake is you cannot do something DML operations directly on top of your data. You cannot delete, manipulate, or let's say insert the particular data. Only it is good for something called selecting of data and checking all those data. But you don't give something called the data governance on top of your data, security, metadata management. All these are the issues which are having with respect to your data lake. For that reason, we use something called as a lakehouse architecture. In that particular lakehouse architecture, it is a combination of your data warehouse plus lake, something called the data lake. It gives all the limitations, whatever we have, it gives with respect to lakehouse. Now, what are some of the open table formats that we can use for doing all these things in something called a lakehouse?
Something, I think delta lake, something is there.
Okay. Something called as a delta tables. We have something called the iceberg tables, and we have something called the hoodie. These are the three something widely used across the industries, open table formats on top of your lakehouse. And using this functionality, your Databricks is working as a lakehouse also, where it is mainly on top of something called the delta tables. Whereas in Snowflake, we can also use this functionality using something called the iceberg tables. Using connecting open table formats using iceberg, I can work Snowflake as well as a lakehouse. Okay. We saw these things. After this, we saw something called the architecture. I mean, how we can use something called Snowflake into our projects, how exactly that particular Snowflake tool is used. And we saw one tool called the Mendelian architecture or multi-hop architecture. What is this?
Where we have different layers like silver, bronze, and gold. Like raw data will bring into bronze, and a kind of transformations we do and keep it like in silver layer. Then any joins or data joining all together will do from silver and keep it in like in bronze. I mean gold layer. From there, the business can take actual data for their reporting and all.
Why it is widely used?
Because we can access any layer at any time.
Can you elaborate on that? What do you exactly mean by that?
Let's say we need bronze layer data which is not cleaned up, so we can access that also. In case we need silver layer data, we can access that. And if we need the final data, that is gold layer data, we can access that as well.
Okay. Okay. Now you have inside your data team, there are wide variety of domain. One is what? Data science people. Another is machine learning. You might be having AI engineers. You might be having data scientists or data analysts. Sorry. These all other different teams are there. Based on their requirement, they can go and access at any layer, and they build on top of their projects or models or anything they can do easily. That's why this Mendelian architecture is widely accepted in modern data tech stack when we use something called the ELT process. Now, what is ELT process?
Extraction, load, and
transformation.
I'm not able to hear you. A lot of disturbance.
Extra.
I'm not able to hear you. Okay, others?
Extract, load, transformation.
Extraction, load, and transformation.
Okay. Now, what's the advantage over ETL process?
where
Like in
we will be transforming the data and loading it. Here we can load the data and then we can get the transformation after that.
Yeah, but I will go and do this, right? Why I need this ELT process? I can transform and I can load to Snowflake.
For large data, we do ELT process, a large amount
Okay.
of data.
Okay, what's the advantage? I want to ask. I'm asking what's the advantage of
we
doing
have, like in ETL, if we will do transformation and if we will load that data, so after that, if we have some changes, we won't be able to do that. In ELT process, we can first load the data and we can do transformation, whatever is required based on the business requirement.
Okay. Now I have a requirement. Okay, let's say this is, let me take this. Okay, this is my source 1. This is my source 2. This is my source 3. This is my source 4. Okay. Let it be. Any source might be there. It is coming as CSV. It is coming as JSON. It can be some data DB. It can be some Parquet data. These are the different data we are having. Now imagine you are using something called the ETL tool or ETL process where you are transforming the data here. I need to collect data. I need to collect data. I need to collect the data. I need to collect data. Combine this and do transformation.
Yeah.
Now you transform that and you have loaded that into Snowflake. Now there might be a situation where another source will come. Now, is it an easy process again go and do transformation?
No, it's not easy.
No.
Has your source increases, or let's say here it was coming 10K records, here it is coming 20K records, here it was coming 30K records, here it is coming 40K records, and you have done all the logic, you have done everything. Mostly ETL processes are having something called UI based tools where you are using drag and drop and you are doing transformation. Now, suddenly, the next day it has increased to 100K. It might increase to 2 million. It might increase to, let's say, 40 million. In this way, the data is keep on increasing. The load on your transformation will also increase. And the scalability is a factor that affects a lot on top of your ETL tools. Now, that's the reason what we do. Go and do, instead of transforming here, I'll take all into my Snowflake or something called the data lake. I'll keep that. Once I have this, all the transformations I will do using something called as a Snowflake, since you have what? Only one single source. Now, since you have single source, any number of source you can go and do, you bring that into one particular data lake or something called Snowflake tables. You have that only one particular source where I can go and work. That's why mostly in your cloud technologies, wherever you go, if any projects are in cloud, ELT process has been used. Now, using for ELT or extracting of data, what are the widely tools we have seen yesterday? Can anyone let me help with that?
Can you repeat?
I said I need to go and extract all the data. I need to bring. I need to use some tools to extract the data. What are the tools we saw?
ADF.
You can use Medallion, Informatica, ADF,
Medallion.
Glue.
Okay.
Glue.
Okay. Matillion. Then we saw Kafka for streaming. We also saw something called as Informatica, which we can use. Some Python. These are n number of tools are there. That doesn't matter. Based on your company requirement, based on your cloud, they'll go and extract those data and do. Okay, fine. We saw these things, and today we'll be getting started with something called as a next part, that is Snowflake architecture.
Sir, I have a question in previous slide.
Okay, tell me. Yep.
So you told that to load, we have different, if you can please go to the previous slide.
Okay.
You told ADF, Glue, everything, right? And we do have so many services like this. Will it be same if we learn like some of these four services, or like it will be different process?
Okay, the process remains same. Wherever you go, extraction and bringing the process same. Maybe the UI for this is different. UI for this is different. UI for this is different. The connection, and you need to understand that. That doesn't mean that there are more than 100 plus extraction tool in the market. You cannot go and learn each and everything. The main thing is whatever widely used, that is ADF is widely used, Glue is widely used. In some of the Snowflake project, Matillion used. And since these are the widely used tools, we'll concentrate more on this. And no company is going and asking. Now, if you worked on something on the ADF and they have requirement of AWS Glue, they won't say that. Now you have worked on ADF. I don't want to consider you, because the main thing, you know, the process, challenges, what all things you are facing in the extracting the data. Same thing will be here. Here and there, the debugging part, everything will be a little bit different. You need to, when you get the chance, you say, I'm willing to work on that if I given chance. So since you know the process, adapting this particular another tool is not a big deal.
Fine. Thank you, sir.
Okay. Fine. So we'll go back and we'll get started something called as a Snowflake. I hope you guys have created a Snowflake account. We'll have some touch base on Snowflake also today. But before going and working on top of Snowflake, the first and foremost thing we need to understand is how does your Snowflake works? Okay, now it is not as simple as on-prem system where you're just directly going and doing all things. You need to understand little bit in the back end how exactly it is working so that it will be easy to work with Snowflake. To understand that, first and foremost, we'll see something called as a architecture. Now, before going to architecture of Snowflake, I'll explain you few architectures that are widely used in market. That is, first and foremost is nothing but shared disk architecture. Now, what do you mean by the shared disk architecture? Now, if you see here, there is something called as a cluster node. What do you understand by the word cluster? What do you understand by the word cluster?
Set of machines.
Exactly. We have a set of machines as you have in your laptop. You have CPU, you have memory, you have RAM, you have disk, all those things. Disk is nothing but a storage. You have RAM inside your laptop, that is nothing but memory. And to run your laptop, they require some power, that is CPU. Now we have a set of cluster nodes. We have n number of set of cluster nodes. This might be your laptop 1, this might be laptop 2, this might be laptop 3, in this way. And you are going and connecting to one centralized disk. Now, what does disk do? Now, we are working with the data. As we know, if the data grows, we need a lot of power to use that particular data or consume that data or do transformation on top of that data. So this is one of the widely used architecture in our on-prem system, where we have one centralized data repository and all n number of cluster or machines have been connected to that using network. Now, what happens here? Now, if you see, we have one centralized data repository. Now, it is distributed across different compute nodes or cluster nodes, and you are parallelly processing the particular data. For example, you are processing something 100K records, and I have a capability to distribute that processing of data with respect to different machines and allow it to go and communicate with respect to your disk and process that particular data. That is happening, and it is happening in parallel, and consistency is there. Now, for example, you are reading, that is fine. Reading can be done using one shared disk is there. You can go and read. Now, from this particular cluster node, you are reading, and from this particular cluster node, you are writing onto the same table. Okay, you have a same table. Now, if you do this, if you remember in your on-prem system, anyone is working in OLTP system, there is a concept called as a deadlock. Now, what does this deadlock do? It makes sure that if a person is reading from one particular storage and the same person is trying to write a particular data, first it allows to complete one transaction and then move on to the next transaction. In the same way, there will be something called as one particular manager or node manager, which will take care of this all locking system. Now, the consistency is decreased because only one disk is there and multiple nodes are trying to come and communicate with respect to that disk. At that time, your consistency will always decrease. That is one of the disadvantage. And what do you mean by this fault tolerance? Now, assume that this particular cluster node is trying to read from this particular disk. For some reason, it got failed. You should not, whatever the operation you're doing, that should not be stopped. So your manager, again, there will be something called a manager. It will try to go and use another cluster node, which is in stale mode, try to consume that whatever the things that was doing from your cluster. That can be done with something called a fault tolerance. And this is widely used inside your something called the OLTP systems. But the problem comes is, as I said, right, whenever you are trying to go and write and someone is reading, there is a slow write always. Locking issues are there. and if your storage keep on increasing, now this is something called coupled with yours, something called as compute and storage. It is a coupled architecture. Now you are increasing this to consume this particular, you have to increase your cluster also. So always there is a chance. Now I don't want to increase my cluster nodes, but I want to increase my something storage. I can't do that. And if the particular storage keep on increasing, there might be a chance bottleneck can happen. The disk cannot sometimes tolerate. For example, you have your laptop, it is having something called the 1 TB of storage it can consume. If you try to go and use all 1 TB and try to do some of the activities, will your laptop works? Will it hang or not? It keeps on hanging. Did you guys see that?
Yes.
Okay.
Yes, sir.
Yes.
So that's a limitation of the particular disk. Okay. Now very hard to scale. Now there is a problem. Okay. Solve this. Now, as I said, this is OLC system that is widely used. Now, to solve this, we have one more architecture called a shared nothing architecture. Now, what I will do is for each of the compute node, I'll give one storage, and I will link that through one of the network. This is a network. I am communicating with respect to different clusters, but the catch is here. This particular machine 1 is only accessible for this. This machine 2 is linked to this. This machine 3 is linked to this. Now, what happens is, now what you did, now scalability you have increased for some extent. Okay, now I want to increase particular scalability, more data is coming. I'll add one more machine and one more particular storage like this. You have increased your scalability. Now massively parallel processing you can do. You can do something called the processing of this particular node with storage, this node with storage, this node with storage. You can do all this. You can do. There is no bottleneck since you are independent. The storage is not consumed by each of the cluster. It is independent. The as many as you can want, you can go and increase. And again, the problem comes is, for example, you have something called as a, let's say 100K records for employee table. Now, how it does, I'm just giving example. It's far more complicated than that. Now it goes and distribute that particular data. Let's say 30K here, 30K here, and 30K or 40K, remaining 40K records have been distributed across the different storage. Now I'm going and reading something called as I said some select star from table where my employees less than, let's say 50K records, first 50K records I need to get. I wrote some statement, then it will go and take this particular records, and from this 20K records will come, and when to display, you should come and join those data and you have to display. Okay, now you're communicating those things. And for example, by mistake, this particular machine, whenever you are running, it has, due to some issues, it is not able to work. Now at that time, this network comes into the picture. It will try to go and communicate with this and try to bring that data. Now, all these things, what you are having is there is a data movement across different storage. Whenever you are doing joins, aggregation across different storage, it needs to come and communicate and bring that particular data. And see, it's very difficult to distribute data if you're not distributing your data across the storage correctly. Now, uneven distribution might happen. For example, here it can go and become 50K, here 20K, and here 30K. Now, this uneven distribution can happen like this. Or for example, here all the 40K, 55K records can, 45K records can come here, only 5K records will come here. Now you are not effectively using your resources. That one of the issues are there. And now I have a table 1 here, I have a table 2 here. Now this table 2 have 50K records. I have one table which have only 10 records. Now I need to go and join these two tables. I need to go and communicate here. Again, there is something called as shuffling of the data happening. For that, we use something called as broadcasting. Now, as I said, all these machines have what? RAM. All memory they have. Now I can go and broadcast and keep that for something called this 10K records. I'll go and copy here 10 records, 10 records, 10 records. I'll go and copy that particular records and I'll try to communicate whenever try to do so that I can reduce this shuffling. At that time, what can happen? Duplication of records can happen. That is one of the things. And more, what you have to do, you have to manage your failures, rebalance, scale out, all these things. What happens? The main problem is the management of this particular architecture. Now you have improved your scalability, you have improved large processing of data, you have more power, but again what? This is coupled architecture where your cluster is something linked to your disk. These all kind of example can I say for your Amazon Redshift Teradata, some of the MongoDB, these are the NoSQL, and somewhat extend to Spark, because Spark is completely different of that. We have driver node, slave node, all things, but somewhat it is a distributed architecture inside your Spark and Hadoop. It also follows the same thing. Now, these are my challenges. Okay. Now I need one tool which can overcome. The main challenge is what? Scalability is a challenge. If your something data is keep on increasing, I don't want to increase my compute. I will go and increase my data and I store data when and where required. Then only if I need to increase my virtual machine, I can go and increase my virtual machine. I don't want any headache of managing these things. How this should go and do this, how broadcasting I need to do, how I need to go and check this shuffling of data. I don't need any of that headache. You give me one tool where I have a best of these two architecture. I will take care of everything. That's where your something called a Snowflake comes into the picture. Now your Snowflake, what it does, it takes a best of both the things. One is combination of your shared disk and another is shared nothing. From your shared disk, what it takes, it is going and giving one centralized repository that can be inside your something called as AWS S3, ADLS, GCP, anywhere one centralized repository it is giving. And from something called a shared nothing, it is giving multiple virtual machines have to go and process that individually. But all good part is there is something called as a cloud service layer inside your Snowflake. Now, what this cloud service layer is doing? Now, whenever you are going and storing inside your storage, it is going and dividing your data into a chunk of something 50 to 500 MB of chunks. They call it something called the micro partitions. Now, what is micro partitions and all? We have dedicated class, don't need to worry about that. But for now, you understand that it has distributed into this micro partition, and this cloud service layer have all that information, what these particular chunks are having. What data is there in this chunk, what data is in their chunk, what data is there in chunk. Now, if someone is coming and from my first virtual machine, someone is trying to read and someone is trying to write onto the same table, it creates another micro partition having all the new version of that, so that if anyone is reading this, they won't come and have that locking system. Now, why this read that another particular micro partition is because your micro partition is something called as, I would say, immutable. Now, do you understand by immutable?
We can't change the data. Immutable means.
Okay. Okay. Others? What do you understand by immutable?
The data cannot be changed in the same memory location.
Memory ID would be different. Memory ID would be different.
Okay. We saw something in Python where at that particular location only we cannot go and do changes of data. If you do any changes, a new particular memory location is created. In the same way, it goes and creates. Now, why it is creating different things is, I explained to you yesterday something called the time travel. What is time travel? On the high level, I explained to you time travel.
Different versions, like if you have made like multiple updates, like 2 to 3 times, like it keeps that version of like as a separate. Whenever if you want to go back, we can switch to a particular version. I mean, that particular data.
Exactly. So to do that, you Snowflake need to know that, right? What is the previous version? That's why it keeps that particular old micro partition. Once that the particular time for time travel is complete, it will go and remove that. That automatically done by what? Something called the cloud service layer. Now I'm taking best of both the things. I had what? Storage issue had, some bottleneck had. Now I had one centralized storage repository where I'm keeping all my data into something called a micro partition. Now I have come up with something called a better version of saving my data. The next part is your Snowflake is decoupled architecture. Now, what do you mean by decoupled architecture? Spelling wrong. Okay. Decouple architecture. What do you understand by decouple? What's the opposite for couple?
Maybe dividing the data or splitting.
I'm saying, what is the opposite to couple?
Decouple.
Okay, individual. Anyone? Now, single. Okay. Are you guys happy being single? Anyone? Anyone here not married?
Yes.
No one? Yes?
Yes.
Okay.
Yeah.
Now I have freedom. Being single, I have freedom. Now I want to increase my capacity of storage. I'll go and increase my capacity irrespective of something called as a warehouse. Now I need more power to consume certain data in my storage. I have that power to increase that particular store virtual machine also. I have that particular thing. So your Snowflake is not tightly coupled from your virtual warehouse and something called as storage. Why? Because there is one layer called as a cloud service layer. It makes sure that whatever the communication you're doing with respect to virtual warehouse to storage, that can be done very easily. All the information, for example, metadata management. What do you understand by metadata?
It stores information about the what kind of data, where it's been stored, how much volume.
Okay. Okay. Now, you have objects inside of SQL, store procedure, views, materialized views, we have functions. And now, whenever you are going and doing some inbuilt functions like date conversion, string conversions, these all are what metadata related work. Or you have a table, you have a rows, you have a columns. All this information has been there inside your cloud service layer. It keeps track of each and everything. So it can directly go and communicate with a virtual machine saying that, okay, you want to work? Go and access this particular micro partition. I have information about metadata, whatever the is keeping with respect to this micro partition. I have that information. You go and work on top of this particular micro partition. So it no need to go and depend on storage because all your cloud service layer is communicating with your virtual machines and it is allowing that to access the particular thing. So in this way, what your storage, whatever the problem was there, compute problem was there because multiple nodes can go and access whatever the particular micro partitions are there that it can go and do. So something called as concurrency also has been solved using something called Snowflake. And main thing was maintenance. As I said, load distribution I don't need to do, manual partition I don't need to do. Everything your cloud service layer will come and take care of something called as infrastructure management. It has its own inbuilt optimizers. Now, based on the data, it will come up with a plan and then it will communicate to your virtual warehouse. Based on this particular optimized plan, it will go and communicate. Now, since you have all the things well maintained, your performance is also increased. Your parallelly processing, optimized way, your micro partition, it keeps on. Now, storage is cheap inside your cloud. You don't need to worry as much as storage. You can go and use your storage. And when and where you don't need time travel, you can go and clean up your backend also. All these things can be done best with something called as a Snowflake. So your Snowflake architecture is something as a hybrid kind of architecture, which has best of both your shared disk and shared nothing. Now, this is a very important question they might ask you. What is shared disk architecture? What is shared nothing architecture? How Snowflake is overcoming these cons you have between these two architecture. Now, are you guys able to explain those things? Is it clear?
So Sagar, here data shuffling will not happen, is it? In the database storage, is it like single system of like multiple combination of systems?
Now, data shuffling will not happen because there will be data shuffling, but that all takes care of by this cloud service layer. It knows the best optimized plan that it need to come up because there might be one micro partition, other micro partition here. Now there is something called the pruning activities, all this clustering. There are a few optimization techniques you can go and apply on top of that micro partitions also. That we will see in the future class. But when compared to other like Apache Spark or anything, now it is much more easy because it is much more faster. This cloud service layer has that capability to take care of all those things because it has something called a metadata management of those all the metadata.
So we could say like with the data available in the metadata manager, which maybe works like an indexing kind of thing, it will go on find out exactly the required information.
Yeah. So that's the reason you don't need indexing also inside cloud because this particular cloud service layer, since have all the information of metadata, you don't need to go and do statistics of all those things. In on-prem system, you might be seeing that if any indexing you have done on the frequent basis, you have to come up with the statistics. What are the keeping of change of data happening, everything, and you need to keep on updating that. Otherwise, your index will not work properly. Here, Snowflake will take care of that all. Are we good?
Yeah, yes.
Okay. Others, are we good? Are we good?
Yes, yeah.
Yes.
Okay. We'll understand deep more before going. I'll just try to explain what all these things, these particular services are doing. Okay, as I said, your Snowflake architecture consists of three main layers. One is cloud service layer. Second is something called the virtual machine layer. Third is something called a storage layer. Okay, as I said, the storage is with respect to what? Something called the S3 ADLS or something Google storage you can go and take. Whenever you go and create any Snowflake account, you might be asked a certain option to create certain what on top of which particular service you need to create, AWS or Azure or GCP, on based on whatever the particular service, particular cloud you select, it will go and create in the backend by itself. Now you don't have access directly to that particular storage location because Snowflake is maintaining that particular internally. Now, this particular storage is what? Highly centralized and highly compressed storage in the form of columnar format. Okay, there's something called the columnar format. It will go and bring this particular data. Now, to explain what exactly columnar format is, let me come here. Okay, now inside your OLTP system, to come here. Now you have a particular tables like this. Okay, quickly I'll show. You have a table. Let's say customer ID. You have a name, country, and age. You have a table like this: 1, 2, SP, XY, 10, 20. I'll take some data. Now, whenever there is something called the row level storage or column level storage, whenever you go with respect to row level storage, what happens? This is one of the row, and this is another row. Yes, these are the two rows.
Yeah.
Okay. Now let me consider this as something called as A0, something A0, B0, C0, and D0. It will go and consider A0, B0, C0, D0. This is one row. It will go and store like this. The next, it will go and say this is A1, B1, C1, D1, and it will go and keep like this: A1, B1, C1, D1. Now, these are the two rows it has kept like this. Now, what happens here? Okay, you are coming and inserting of data. You can go and easily insert the data. You are coming and updating the data. In this particular data, whole rows need to update. You can do. You are going and deleting the data. You can go and delete easily. But if you're going and doing something called the aggregations, you're doing something called selecting of certain columns. Imagine this has 10 million rows. It has kept like this. It has to go, even though you are selecting only, let's say age is aware, I need to go and do aggregation. It needs to go and fetch each and every rows like this. It needs to go and scan. Yes or no?
Yeah,
Yes,
it
sir.
has to.
So this is a problem when we go and do something called the analysis. Fine. OLTP system where you are doing all DML operation, you bring and keep, that's fine. But inside your something OLAP systems, I no need to go and keep like this. I want something where all the something called the customers. If I have something called as, let's say A0, A1, I'll keep one way. Let me remove this. Okay. I have what? Let's say I have A0, A1, A2, A3. For example, I'm taking, I'll consider and keep in one particular column. Now, what are you doing? All the columns you are storing in one particular way. And next, you will go and keep your B0, B1, B2, B3. Next, you will come and store your C0, C1, C2, C3. Next, last and foremost is D0, D1, D2, D3. Now imagine you need to go and do what? Aggregation on top of the, for aggregation of age, I can only go and fetch this particular storage. Can I do that? Is it required to go and scan all these particular different rows now? Is it required to scan this
No.
block, this block, this block, if I need to go and do aggregation on top of my age? Did you guys
No, it's
understand the
not
question?
required.
Okay.
Only
No.
only the block which has A, we can deal with it.
Yep. So
Yes,
inside
yeah.
your OLAP system, what happens? Now it is much more easy to do analysis on top of your data. So all your OLAP system try to follow something called as a columnar format. Now your Snowflake take care of this. You no need to worry. It automatically does this particular columnar format. Yes, this is which is where did I share? Okay, it went up. Now your Snowflake will take care of that particular columnar format. It automatically take care of that, and it is done something called a highly compressed format. Now, what do you understand by compress? What do you understand by compress?
Data by doing data compression,
Reduce the data
can
size.
save the memory storage.
Okay. Okay. Now, if you see, whenever there is something called a zip file inside your computer, you guys use this zip compression.
Yeah. Yes.
You have a 10 MB of file. Try to go and use this zip and compress that. You will go up to 2 MB. Right?
Yes.
But if you want to read this again, what you have to do? Come and unzip. Yes,
Yeah, we need to unzip again.
Now you don't need to worry. Now Snowflake has something called the cloud service layer. It will take care of that. It will communicate to zip and unzip. Now whenever it is trying to go and store anything, you can go and compress the format and automatically decompresses using cloud service layer using virtual warehouse. Now I don't want to go and zip the form and keep. I need to keep as it. You have option for doing that also in with respect to your storage. So your cloud storage, whatever, since it is not coupled, it can easily go and increase whatever the data is storing that is there in the form of micro partition. You can store in the form of micro partitions. We'll explore more on micro partition in coming days. Don't worry. We have one dedicated class for that. It's a very important topic for Snowflake. And all these things we are done with respect to storage. Fine. Now, what does your cloud service layer do? Okay. As I said, one of the main important thing is metadata management, where it is going and doing all the metadata information, everything it is going and doing. Now, what does the infrastructure management means? Okay. Now, with respect to your organization, now you have organization, different accounts, users, roles, all those things also will be taken care by your cloud service layer. It makes sure that a particular user or particular role have access for the particular objects. Now, using what? Something called as authentication and authorization. What's the difference between authentication and what's the difference? Authorization. Authentication and authorization. What's the difference between that? What's the meaning?
Checking if is it the right user to log in or like to fetch data, whether he had proper mechanism.
Okay.
Authentication, like once you give a username or password, whatever, is like just checking if it's valid or not. I mean,
yeah. So authentication is what? Now you have joined any particular company. Okay, we are going a particular company and you are trying to. This is your first day and you are trying to go and go into your company. There will be a security, right? He'll go and say, "Who are you? Why are you coming?" You don't know who are you. He'll ask show your ID. Now, if you don't have any authentication to go inside, will he allow you? Will he allow you to go inside?
no, he will not.
Okay, you cannot go now. You cannot go now. Tomorrow you cannot go Microsoft company and you say, okay, I want to see how the company is looking inside. Can I go and have a walk? You cannot go and have because you don't have authority. You only if the particular authority is given, you can go and inside your Microsoft company. Now imagine you are joined Microsoft. You are going inside. You are given authentication. Now you can go and go inside. But there will be something called a server room. We have seen server rooms yesterday. What is server room doing inside the company?
Which have kind of data is stored across racks.
Yeah. So all the servers we have, all the important where all your computers, everything is running with respect to your company. Now, even though you have authentication to enter a Microsoft building, now you don't have authority to enter this particular server rooms. Why? You are not an admin. You are just a data engineer. Your work is to come and work on data, not go and see something called a server. Now, all these things, now I need to go and give access for particular database. I need to go and access for something called as a tables, a column schema. I need to do something called as a row level security, column level security, masking of data. Write a piece of code, but your cloud service layer will come and make sure that whatever the authority and authorization you're doing, that can be taken care. Okay. Now I said optimizer. What optimizer does, it comes with the best plan and it makes use of something called as a cache. Now, as I said, if anything is there in memory yesterday, we can easily go and use that particular memory, and the load on the particular server is reduced because you're reusing the whatever the things are there. It is the particular machines remembers that is there in RAM. I can go and use. Now there is something called as a cache inside your cloud service layer also. If that particular cache is there here only, it will go and read, or else it will go and make use of something called a virtual machines cache. It can communicate between these all things using, and then come up the optimizer. Then there comes something called security. Now there might be some certain compliance that particular company needs to follow. For example, HIPAA compliance, or when you're working with healthcare things, you're working with all other things, all the security features need to be taken care. That also you are something called as cloud service layer will take care. Now, once this particular cloud service layer is mainly for what? Now, what is the one main organ in your body? Without that, your life is useless. I would say the main one important organ.
Brain.
Heart.
Heart.
Brain.
Okay. Now, without heart, you cannot live only. You are living your life, but without brain, can you do your day-to-day activity?
No.
Now I'm teaching you something. I'm making use of my brain only to communicate with you guys. So you can say your cloud service layer is what? Is a brain of your something Snowflake. It take care of each and every activity your Snowflake need to do on the high level, but it not goes and stores the data. Data is still inside your storage. Some memory it has to come up with a plan. It can store up to certain things, but as soon as you something clearing of cache and all you do, it will go. It's a temporary storage I can do. The permanent storage, whatever you can do, that is done with respect to your storage. Okay, fine. Now there is something called the virtual machines. Now what machines do? Machines are the way is exactly required to do all the operations inside your Snowflake. You're doing joins. You are bringing the data. You are inserting the data. You are doing all those things. Your machines come into the picture. The more complex the data, whatever the query you write, it requires more power because it needs to go and handle more data. Your virtual machines, you can go and increase. You can increase vertically. I mean, you can increase the configuration of one particular virtual machine inside your laptop. If you want to go and increase your configuration, you can do. Or else if you have PC, you have multiple CPUs, you can go and connect and you can increase the power of that particular machine also. You have capability of doing that. That's why it is called a multi-cluster warehouse, where we can go and add n number of virtual machines as much you want. And in one particular virtual machine, you can go and increase the power. Your something called a Snowflake will come up with something called a t-shirt size virtual machine from XX to 6XL. That means as soon as you increase the size, the power of that particular virtual machines will also grow. Beyond 6XL, if you want, I'll go and add one more virtual machines, and it can easily go and communicate with your data, and that all things can be taken care by your communication can be taken care by your something called the cloud service layer. Now, these are the three important layers that are working independently, and all these things are hosted where something called as a virtual private cloud. Or you can say on the cloud, whenever you go and configure your Snowflake account with respect to the cloud, if you're saying Azure, in the Azure, for doing all this power, they provide Azure virtual machines to do all these things. Whatever the power it requires to communicate, that power will become with something called the Azure virtual machines. If you go with something AWS, EC2 machines will come into the picture and you can go and communicate. In this way, the power what to communicate everything will be taken care by from the clouds. Storage will be taken care by clouds, and optimization will be taken care by cloud service layer. This is how your Snowflake architecture works. If you have any doubts, do let me know. Are we good? Are we good?
Yes.
Can you explain me briefly?
Sagar, VPC, can you explain one time? Last point, what you said.
It's a cloud. Now, if you want AWS, now you have hosted your application on AWS. AWS service is taking care of this. You have hosted in something called Azure. Azure services in the backend. You need a power, right? virtual machine is what? Some power you need to give. That power is being given by this particular private cloud, or whatever the cloud you go and take, that particular cloud will give the power.
Yeah, got it.
Okay, fine. Can anyone explain briefly, quickly?
Yeah, yes, Sagar. As part of like cloud services, it is like main important service like among all the Snowflake architecture. Among the infrastructure manager takes care of like splitting the data into micro partitions and to take care of authorization and thing and interacts with your virtual machines. All the authorization things will take care of by infrastructure. Optimizer, it's like any virtual machines having a cache data, best execution plan, how to retrieve data, how to store the data, which one to process the data. So all things will be taken care by optimizer. And metadata manager, each had like all information about like functions, how much volume of the data, where the micropartition got stored, kind of thing. So it acts like an indexing and better retrieval or like processing it use. Security just protocols. I mean, all the HTTPS or like whatever protocols it takes care of. And virtual warehouse, based on its capacity and storage, is try to perform its operations. If you want like more complex operations, we can add and like corresponding virtual more warehouses. First, and data store like is scattered across like in the cluster in the multiple nodes. Based on scalability, we can increase more and more. I mean, if needed, like yeah.
Yeah, good. Thank you. Hope everyone is good till now. Can you guys give thumbs up? Reaction? Something? Are we good? Okay, thank you. Now, we understood all these things, but on the high level, how does that actually work? I said cloud service layer. This comes with something called as what? All the layers are there, everything is there, where it is keeping care of that. Authentication, everything is there. Now you went and executed one particular query, select star from my table 1. Now, when you do that, how does these services communicate with each other? First and foremost, your cloud service layer will come into the picture and it checks whether this metadata is present in my particular micro partition is there. If it is present, and it will go and check whether you have authentication for this particular table or not. If everything is there, then it will go and check the query, whether the query you have written for this particular select star from this particular table, is this particular query is correct or not. If all these things are correct, it will go and come up with the optimization. It comes up with the best optimization, and then it submits that particular query. After checking this all IAM role authentication, everything, all this goes and it come up with the best optimization, and then it will go and submit to what? Next layer, that is virtual warehouse layer, because that is where actual this particular bringing of data is doing. Transformation is being done. Now it takes, now since this particular, whatever the virtual warehouse is there, allocation is done. Now this cloud service layer will communicate which virtual machine, which is in ideal state, whatever the things is there, it will come and communicate, and it will go and scan and process the data. Now, if something you need to go and increase the power, there is something called the QS. I'll explain you QS when we have something called the virtual warehouse classes. In that time, I'll explain. Now I need more and more workers. It will go and extend that particular workers, and all these things your virtual warehouse will do based on the data that is processing. Now, whatever the things you have there, it will communicate with your virtual warehouse, storage layer. This particular storage layer, it will always go and communicate with each other. Now it brings process data, everything it does, and again it needs to go and communicate with the brain. Once you do all the tasks, you need to go and communicate with your brain. In the same way, it will go and communicate with that particular brain, and it will inform the cloud service layer. Okay, my task is done. This is what you can go and display to the user. Now your cloud service layer come and display, but you are coming and running the same query again. Now your Snowflake is much more intelligent that it will go and cache that particular information here, and it will cache those information here also until that particular warehouse. Now, if the cache information is inside your cloud service layer only, it will go and display. Now, due to some layer, this cache has removed. It has one more cache inside your something where virtual machine. Unless this virtual machine is turned off, this cache will be there. and it will, whenever you go and execute the same query again, it can go and display. In this way, your Snowflake will try to come up with the best optimization plan. And that's the reason wherever you go to work with something data, it is much more easy with respect to Snowflake because you no need to worry in the backend work, whatever it is happening. The only thing I need to worry is how well I can write my code. If I write my code pretty well, now since it is taking almost 80% of the task, it is taking care. Now, if you that 20% also, if you take care by yourself, now your code will be much more optimized and you will get a much more better result. Now, one thing you need to remember that how does Snowflake charge the customer? Now, I said your storage is not coupled with something called as a virtual warehouse. Now, how much data you are going and storing with respect to the cloud? They are going to charge per TB a fixed amount. They are going to charge. Whereas virtual warehouse, whenever you are going and processing, for example, I process only 10 minutes. I use my virtual warehouse. They were going to charge only for this 10 minutes. Now, based on the size of your warehouse, the charges will keep on increasing. That we'll see in the virtual warehouse class how that charges are done. But since this is something called the decoupled architecture, the charges for the companies also decrease because based on whatever the virtual machines and storage you are using, only for that you are using. That's why your feature called pay per usage feature will come into the picture, where you are using whatever the use you are done. Based on that, the Snowflake is charging for you. Are we good? How it's working? Any doubt in this?
Yes, sir.
Okay. What about this? Are you guys following? Are you able to understand?
Yes, sir.
Okay, thank you. Fine. Now comes with the addition. Okay, we saw architecture, everything that's fine. Okay, Sagar, we understood how Snowflake is working and all. Now I need to go and work on top of your Snowflake. I need to create my account. Now, yesterday I gave you a particular document to go and create a particular Snowflake account. Now, while creating, it was asking different edition. Did you guys check this? No?
Yes. Yes.
Okay. Now, what are these different edition? Now, based on your requirement, Snowflake says, okay, now if you don't have much, like very large amount of data you are processing, simple data, you are a startup company, you are exploring cloud data warehouse things and all, without much advanced compliance, you don't need, I just need to go and get started with Snowflake. I need to make sure that my whether this Snowflake is best suited for my organization or not, or my company or not. I need to come up with that. So they say, okay, I'll give you something called standard edition. When you use something standard edition, the features, whatever I'm giving are the basic feature. Core functionality of Snowflake will remain as it is. Compute and storage all remains as it is. Security will always remains as it is. But other things called as a time travel. Now, as I said, the number of days you can go back and bring the data of your historical information, that will decrease only 1 day. Max up to go, we can do 1 day. Now, what is this fail safe? I'll explain you in some time. Now, all this basic information, basic standards, I can go and I'll give you standard edition. Okay. Now you come up and you saw, okay, this particular Snowflake is best suited for my company. Now I need a best edition where I can go and do my day-to-day activities. Then they say there is something called the enterprise edition, where I'll go and give you time travel up to 90 days. There is an extended retention time, other enhancement, whatever the resource enhancement, optimization, everything, whatever is there, your cloud service layer is much more optimized here. All that take care. And it is where your retail is running, reporting, transformation, everything they are doing, they will give this particular information. Now, there is some of the companies, they have some business critical or sensitive data. They need to follow some more sensitive data they are keeping. Now they need security, more and more information, strict security. There comes something business critical. All other features of your enterprise remain same. Apart from there is more enhanced policies, encryption, decryption. As I said, it is going and keeping in a compressed format. And this particular format is encrypted format. No one can easily come and read that particular data. Now, while reading whatever that data is there on the something called the stale mode, also that should be in an encrypted format. And whenever you're reading, that should decrypt and give only for the authorized user. All those more high level compliance you can go and use with something called the business critical. Now what happens whenever you go and use all these machines? They are going and giving you a cloud, but there might be a situation As I showed you something for the server room yesterday, one particular rack will be given for you, another rack will be given for another company. Now I don't want that. The whole server, whatever is there, I want for me only. Then you can go and communicate with something called the Snowflake, and they will give one particular warehouse dedicated where no other company can come and keep those information. This is more highly compliant. Now, based on your requirement, you can go and take. Now, apart from there is one more enterprise edition called the Matrix edition, where they have for this is mainly for your AI ML processing. They have more something called as a CPU and GPU, where you need a graphic card for processing and all. If your company is dependent highly on something called as machine learning or building LLMS models or coming with streamlined applications, then you can go with something called as a Matrix edition also. Now we'll be widely working with something enterprise edition. Why? Because we have most of the features with respect to enterprise edition. We'll try to understand. Now this all comes with admin work later on, whatever the edition. Now once you're good with this edition, we can easily go and work with any other edition. Any doubt in this? Any doubt in this? Are we good?
Sir, which model, like which edition is generally used for Snowflake, like while we are working with the client?
See, most of the companies will go with the enterprise edition, but as I said, if they are business critical, some very important securities are there, and they want to keep a virtual private cloud, all those things, it depends on the requirement of your client. Okay. If they are okay, because here you are going and increasing this edition, the payment for this particular edition is also more. It's not like simply they are giving because they are giving different features, right? They say I will charge more than what is there. Now inside cloud, you can do n number of things, but only one thing is you have to have always the control over the cost. If you are unnecessarily using the services, the cost for the company will increase like anything. So it depends on your business use case. First, most of the company try to go with enterprise, but if they have any business critical and all, they try to go and use those other editions.
And we can upgrade it timely, like we are using enterprise, and next year
yeah, that you can individually cannot do. You have to again connect with something Snowflake, and then they will help you out.
College.
Okay. Fine. Okay, Sagar. Now the everything I understood and edition I understood how Snowflake works, everything. Now, what does the objects looks like inside your Snowflake? Now, before entering, I'll just show you a brief introduction what are the objects are there. Now, whenever you go, there is a one organization. Let's say you are an organization of Microsoft, or let's say you are not a Microsoft. Let's say you are a company. Let's say XYZ company. They are using something called as particular Snowflake. For that particular organization, I'll go and create one account. This might be a dev account. Now I want another account for QA account. I can go and create prod account. Any number of accounts I can go and create like this way. And now one under particular account, how exactly it looks like. Now, whenever you go with respect to account, there are different objects that are there. One is warehouse. As I said, warehouse is where you are giving, this is a virtual warehouse. Okay. Now, don't get confused with data warehouse and this virtual warehouse. Virtual warehouse is where it is giving power. Data warehouse is where you are storing the data. Okay, that's where you're storing. Now you have that. And database is where you are exactly store your data. And then you have roles, users, and other objects, whatever there with respect to any other objects that is there with respect to account like AI/ML objects, reporting objects. So many objects, features that will give that will come under this. But under database, where you are going and having one schema, and under schema you have tables, views, stages, store procedure, user-defined function, and if any other objects like file type, you have something called as stages. So many things will come. I'll explain you that. But this is a high level how your objects looks like. Your organization, your account, database, schema. Under that, you have different types of objects. Now, what are these pipes, streams, tasks? I will explain you. Don't worry. But these all objects come. And apart from that, any warehouse users, resource monitor, integration, shared object, these all things comes with respect to accounts. Now, apart from that, there are different roles. Now we have one dedicated class for roles, but on the high level, you need to understand, because now when I'll be showing you Snowflake, you might get confused. Now one is something called as an account admin, where you have a highest privilege. Each and every features with respect to Snowflake, we can go and work. And there is something called a security admin, where you are going and doing with respect to managing of users, roles, grants, all these things. Under that comes something called the user admin. That is a sub part of your security admin. Now you want to go and manage this admin work. The security admin whatever the role is given to that particular user. No, I want to go and create a custom users, manage my database. I need to create my something warehouse, everything that will be done with respect to something sysadmin. Now, all this, there is one public particular role that it has the least privileges, but all this information will come. Now we'll get started with something called the account admin. We'll see all this thing. When we come back to something, one particular cost where role-based access control, at that time we'll see how to create a role, what's a custom role, all these things we'll see when we come back to that. That being said, let me come back to my Snowflake and I will show you a few things. Before getting started, I will go till now.
Yes, sir.
Okay. Now, as I said, whenever you go and create any particular account and you log in, now login things, authorization, everything is taken care by what? Which service that will take care?
Or cloud services.
Okay. Cloud service layer will take care. If you have access for this particular Snowflake account, you will be able to come and log in. Now, once you come and log in, this is how your Snowflake looks like. Now, they have changed their UI a little bit. They have added a new thing called as a workspace. I will explain what is that workspace and all. But for now, you go to something called as settings. There is something called as general here. There is set a default workspace has SQL editor. You go and uncheck this. For now, I'll explain you what is this, all things. For now, go and uncheck this. Now, once you come here, you have different like projects where you have ingestion, we have transformations, we have AI, ML, monitor, marketplace, catalog, all these things we'll see. For now, I need to go and create my particular table, or I need to go and see access all the information I want. Now, when you click here, there is something called, let me refresh this. Now, once you come here, you see, once you uncheck this, you see there is something called a worksheet option. If you check this, there will say SQL file. Now I have uncheck this. Now, once I click on this particular SQL worksheet, a particular worksheet will come up. Now, this is called as a session where you are going and working on top of your all the objects inside your Snowflake. Okay, now I have this particular information, everything. Now, if you come, there is something databases there. If you have different worksheets, that it will show here. And let me minimize this for now. By default, Snowflake will give some sample data for you understanding. And whenever you go, there is two default schema. One is something called as information schema. It's all the information of inbuilt features of Snowflake. They keep on tracking all the things, whatever you do. That information schema is kept here. One public schema, they will give you default. If you want, you can go and use this particular schema. Okay. And they are given some sample data. All these things they have been given. Now I don't want that. Now I need to go and create my own database. I will say create. Let me increase the font. Okay. Or replace database. And I'll give my database my demo DB. Okay. Now it's not mandatory you create or replace. If you want only, you can go and say create database. I want to show you this replace also for SQL batch student. So I said create or replace. Now, if you see here, there is something called the compute warehouse. Can you see here? Can you see this?
Yeah.
Okay. There you see something called the account admin. When I click all the roles, these are the default roles which have now using something called the default as account admin. And you see something called the compute warehouse. Now this warehouse is of what? Excel size. Now when you come and click on that, you see here. And if you want to see different sizes, these are the different sizes you have. Now, what state it is in there? What is the status?
Suspended.
Okay. Suspended. And if you see there is gray color, it is not a active state. Now, if I come and resume it, can you see here green mark?
Yeah.
Okay. Now your virtual warehouse is in active state. Now, as much as your time you keep this particular active state, the cost for the Snowflake will keep on occurring. Even though you're not running any queries, you're not doing anything, but you have kept your virtual warehouse on active state. As much time you keep that active state, the Snowflake will cost. Means they are going to charge you. Now, if you say something here, auto suspend and auto resume, what do you understand by this?
If you don't do any operation.
It will get suspended in the given timeline, like how it is set to 600 second. Like after 10 minutes, it will get suspended, so that like we will not get any cost after that.
Okay. Now you are not doing. Now I just on my particular something called started. I'm not doing anything for 600 seconds. It will automatically go and suspend that because you Snowflake make sure that no extra charge is cost when it is idle state. Now I said something auto resume enabled. What do you understand by that?
When you try to execute anything, it will get enabled automatically.
Okay. Now you are trying and running. Now you don't need to go and automatically resume the things. If it is in suspended state, it will come and resume. For now, I'll go and suspend this. Okay. Now your Snowflake is what in suspended state. Now I'm coming and I'm running this particular query. I said create or replace database, my DB, and I run my particular query. Now, as soon as I run, all the information, whatever the things is there, it will give here. And if you come and refresh this, one particular DB is created. By default, information schema and public schema has been created. But did you see what is the status of your warehouse?
Suspended.
Okay. Now, why you guys think it is still suspended?
It start working when we do some computation.
For a DDL operation, it will not use perseverance.
Okay. Now, is it a kind of metadata? Is it a kind of metadata?
No.
Yes.
Now, this is a metadata.
Yeah.
And which layer will take care of metadata?
Infrastructure services.
The cloud service layer knows that I no need to have any power because I'm not working with what data. I'm just creating what? One metadata I'm creating. I have that particular power. You no need to go and use this particular metadata. Now I'll go and say same thing. I'll go and come here and I'll say instead of database, I'll say schema. But here I'll say my demo sh. Okay, I'm giving one schema like this and I'm going and creating. Now, is your data warehouse started?
No.
Okay. Still, it is in suspended mode. Okay. Now, let me bring one table. I don't want to waste time because we can easily go and create a table. Let me see that table where that code is there. Okay, I have this particular code. Now, I went and I created one particular table. Now, where I'm creating? Under my demo DB, under my demo schema, under that I'm going and creating. Now, if you come and see here, are you able to see the database and schema?
Yes.
Yeah.
Now, if you want, we can go and access different schema here. Now, if you don't mention anything here, automatically it will go and take whatever the schema and database you have been shown here. It will take care of that. Now, I'm being in this particular database. I want to go and create a particular table in different schema. I can go and access those information there also. Okay. Now it is not showing here because I need to refresh the page. Let it be. Now I'm going and creating my table. Okay. I created my table. What's the status?
Suspended.
Okay. Now why all these things are being suspended mode? Because there is something called the metadata. You are not working with the data. Now let me insert something. Okay. Let me print the code. Okay. There's a code. Now I'm doing certain things where I'm inserting my data. I run this piece of code. What is the status now?
Started.
Okay, because you started working on top of your data. Now your virtual machine comes into the picture. Now your storage will come into the picture. As soon as your virtual machines and storage comes, you need something called as what? Compute layer. Okay, now you're working on top of that. Fine, fine. That is fine. Now I'll go and suspend again. Okay, I'm just doing what? Select star from my table. Now you tell me what might happen.
It will get started.
Okay.
It will start.
Okay. Tell me if it will get started. Why it will get started?
Because
It
you
has
are
to fetch
fetching
the data from the storage, and from storage data has to pass to virtual machine, and it has to display on the UI layer. I mean,
once you run this again, it needs to come and communicate because that particular data is not there. So it will go and see. Now, if you see here, it is showing something called as 665 milliseconds. Okay. How much data it been processing. Now we have a class. Don't worry. What is this compilation, query processing, execution? We'll see that how this particular cache is working. It took something called as 665 milliseconds. Now I'm going and running the same query. How much time it took?
59 milliseconds.
Yes.
Now, how all these things are happening? Because there is something called as cache. Now, if you come and see, only compilation that is taken time, execution it has not taken. All the caches are there. Your cloud service layer will communicate with your virtual machines and everything. Now it is not going and hitting your storage. If that particular data is cached, it will bring from that particular cache. Are we good?
Sir, but it should be active now when you have created like table. You have created a
Yep.
schema and
Yep. Now, if I go and suspend this now, okay, I've suspended this. Now cache is cleared. Now I'll come and run. How much time it took? Now still it is able to bring that because why? The virtual warehouse got cleared. As I said, the cloud service layer also have cache. It also have some cache. Now that data is there in cache of cloud service layer, it is able to run. Now what I'll do, I'll just refresh. This is the issue. Okay, fine. I want home. Whenever you refresh, it is automatically going to that SQL sheet. Okay. Now I have this particular thing. Now you're suspended state. Now I'm coming and running. It might. Now it took more amount. Now it has some time limit until that particular cache is there in your cloud service layer. After some time, it will remove that particular cloud service layer also, and at that time you will be not able to do. If you go and log out and log in, at that time maybe the amount taken to process the data will be much more compared to that whatever you are able to see.
It
All
remains
this
in
is
cache
happening.
throughout the day.
Sorry,
It remains in cache throughout the day.
I'm not able to hear you.
It remains in cache throughout the day.
Throughout the day unless you are completely logged out with your cloud service layer, then it will refresh that. You don't have that particular provision to go and flush that particular from the cache. Snowflake will take care of that. Okay. Fine. Are we good till now?
sir, like when you are executing the query, so it is getting active. But like when you have created that database schema and table, so at that time, like it should be active now because we are creating table in the database schema.
That's what I
Like
said.
in
Now, these
warehouse.
are all other metadata information. Metadata is taken care by why? Cloud service layer. Cloud service layer has some power. It will take care of that.
But whatever table that we have created, that will also get stored. No, so
Metadata information. Metadata information, I'm saying. That metadata information, it will be taken care by your cloud service layer. It is going and creating micro partition. As I said, micro partition is created. Now all that information, it will go and whenever you go and work with data, it will give that information to database. At that time, it creates that. Got it?
got it, sir.
Okay. Now we saw all these things. I'll introduce one small topic. Okay. I say something called as show tables. I'm saying whatever the tables are there, you go and show me the tables. Now this is my table. Okay, for now, let me remove this. Okay, this is my table. All the information about table, when it created table, everything is there. Now rows are there, whatever, who created this. Now you see something, there is a retention time. Are you able to see?
Yeah,
Yes,
we
sir.
can able to.
Okay, you have something called a retention time. Okay. Now I do same thing with respect to schema. Can you see here retention time 1 day?
Yeah.
Okay. I'll do something called as a database. And this is your DemoDB database. And you see retention period as 1. Now, what is this retention period? Okay. For everything, it is giving us 1, 1, 1, 1. Now, if anyone is using something gallery inside your phone, if you go and delete a particular pic, there is always something called the recycle bin. Have you seen this inside your gallery?
Yes, sir.
Okay. When you go inside the recycle bin, it will show it says past 30 days data or past 30 days, or let's say for some, it might be 7 days. Based on the model, it will show based on past 30 days, whatever you have deleted. Right? Okay. Now, this retention period is nothing but, now this is what it is retaining. Some, even though after you have deleted, you have done everything, it is retaining that information by itself. After 30 days, more than any pictures that are more than 30 days, automatically it will go and completely delete that. This is retention period is nothing but how long your DB, schema, or tables need to maintain historical information for time travel. Now I said 1 day. Now I'm doing a lot of DML operation on top of my what? I'm doing a lot of operation on top of my DML operations. Now I've done an insert and one go. It goes and keep at what time this particular insert is done. I've done 10 update. It goes and track that how much I have done. I have done something called as all the select things I have done. Update I have done. I have done 10 deletes, or let's say 2 delete I have done. All these things you have done, and at the end, permanently you are able to see the data, what is there at that particular point of time. But I need to go and fetch my information before before I do, let's say 10 updates, whatever the data is there, I need to go and fetch that information. Now, how long you can go and fetch that information? This, if you have done 2 days before, and your retention period is 1 day. As I said, after 30 days, that picture will do what automatically?
Delete.
After 30 days, auto delete. Now you said retention period is 1 day. Now after 2 days, you come and see automatically what it will do.
It will delete the data.
Okay, all this information of DML operation, whatever you have done on top of your table, you will delete it. Now, if you are done retention period, you can go and set what? 7 days. Up to 7 days, it can go and track. Now, if you're coming and seeing second day, it will be there. If you're going and see third day, fourth day, fifth day, seventh, up to 7 days, we can go and track all the information, whatever be. That doesn't mean you are changing your data. It is a historical information. Whatever the operation you are doing on top of your table, that can be tracked with something called the retention period. So with respect to Snowflake, Enterprise Edition, you can go and do max of 90 days on the object. You can go and put historical information. And when we come back tomorrow, we'll see what exactly this retention period, what is this time travel, what is fail safe, how we can go and access this particular historical data. All these things will come back and we'll see tomorrow. If you guys have any doubts, do let me know.
So Sagar, you are executing this select statement, and it is starting the uh, it is resuming the computation, and it is taking some time. So if you execute the query with some bug, so that will also charge you amount. Right.
Yeah, and unless you are using something computation, it will charge.
Okay, so every time we need to make sure that we don't have
Now
any
I'm
bug
saying
in our.
select C1 from my table. Is C1 present in my particular table?
No.
Okay. I'm running this. Now, is your compute started?
No.
Why it did not start?
Because query failed.
Why it failed? How it come to know it failed?
Okay, in the metadata, it might have checked whether this column is exists or not. So it's not exist, so it didn't went into computing.
So your cloud service layer is taking care of that. Now this column is only not there. You have entered a wrong column, so it is throwing here only. It is not. It is not using any your computation. Got it? Have you got? Okay. That's it for today's class. If anyone have doubts with respect to the course, please let me know. Anyone who joined new today and have doubts with respect to the course? No one? Are we good?
Yes, yeah, good.
Okay. So I mean that you might have watched the yesterday's recording, right? If you guys don't have any doubts, did you guys go through that? Anyone new?
I'm new, but I haven't watched yesterday's video. Just being here today.
Okay.
Today's session was good, and I'll check the yesterday's video and get back to you tomorrow.
Okay. If anyone has missed yesterday's recording, it's there in our YouTube channel also. Go and check on that. I explained deeply at the end how the course or whatever the things are there. You can come and connect with Mahesh or any other admin team. They'll help you out all the information. Or if you have any doubts with respect to the course, again, we have 3 more demo classes. You guys can come and ask. I'll be there to help you out. Are we okay for today? Shall we close the class?
Yes.
Okay, thank you. We'll meet again tomorrow, same time, 8 o'clock. And those who have not created Snowflake account, please try to go and create. And one thing I want to inform that, try to choose something called the West US location from AWS. Don't go with a Singapore location. Some AI features are, inbuilt co-pilot features. I'll show how to write a code and all. That is not supported with all the regions. That is supported with something called the West US. Try to use that to create an account. If you are not used, if you are already created, that's fine. If anyone is creating as a new, try to create using West US region. Okay. I got.
Sagar, which edition do we need to select? I mean, I have selected the standard. Okay.
No, enterprise edition. You can create one more same particular Snowflake account using the same email ID. That will not throw any error. As many Snowflake account you want, you can create.
Okay, sir.
Okay, fine. Always go and create enterprise edition. If you have done any other edition, please go and create enterprise and try to use something called the region is West US. Okay, fine. We'll connect tomorrow. Thank you.